median, right? So median is the segment whose endpoints is a vertex, right? And the midpoint of the opposite side, right? So I start where I have one endpoint at a vertex, and then the midpoint of the opposite side, right? So I have to have those congruent marks there to tell me that that's the midpoint. Okay. So each triangle, right, will have 3 of these because there are 3 vertices, 3 sides. So if you draw all 3 of them in, all of those lines will end up meeting at one point. So that's what we call the centroid. So, and then one thing to know, the centroid, right, always on the inside of the triangle. So like when we look at that, we look at this here. C here is the centroid, right? It's where those 3 medians intersect. So there's a relationship that happens once I know where the centroid is as far as the length of the segment and the 2 smaller parts of it. So the idea is here that this whole median, right, FH, from F to C, so from the vertex to the centroid is 2/3 of the whole thing. So 2/3, right? 2/3 length of the whole thing. So you kind of have these, they give you 3 equations here, right? Just knowing that from the vertex to the centroid for any one is 2/3 of the whole length. So the types of questions you look at is just kind of finding those missing side lengths. So what I would start with here is I would say, okay, XA, right? So we're talking about that segment there. They tell me that is 8, right? And I want to know what is XB, right? So what is the whole thing?
16.
So I want to look, and I want to say, okay, XB is equal to, actually 2/3 of XB gives me XA, right? So that's using that relationship, just 2/3 of the whole thing gives me XA. And if I know that XA is 8, I'm just going to use that. I'm going to plug it in and say 2/3 of XB is equal to 8. So now I've got to undo that 2/3, right? How am I going to undo multiplying by 2/3?
Multiply by, yeah, you multiply by 3, right? Both sides.
So you could do that. I would multiply by 3/2, right? Because if I multiply by the reciprocal, I undo the whole fraction all at once. So XB equals 12. Is the altitude. So the altitude starts at the vertex, right? So it's a segment from a vertex of the triangle to a line containing the opposite side. So we'll talk about what that means as far as containing goes. So altitudes, right, can happen inside, outside, or on the triangle. Right? Inside, outside, or on the triangle, an altitude can be. So if I think about kind of this triangle here, right? PR is my altitude, right? So, right, I have an altitude there. And so if I notice, right, I start at the vertex P, but that whole idea of the line containing the opposite side is because I had to extend SQ in order to get that perpendicular relationship, right? So that's what they mean by the line containing. Sometimes it's going to kind of extend a line, and they'll show it by that dotted part. Other times, like if you look down here, right, in an acute triangle, they're on the side of the line. So these 3, right, if you draw all 3 of your altitudes, right, they're going to meet at a point that we call the orthocenter. Okay? And so the ortho center, if it's an acute triangle, right, is going to be inside, right there. Right triangle, it's going to be on the triangle, right? And these two are the altitudes. And obtuse triangle, it's going to be outside the triangle. Okay? So, last thing I want to kind of point you to is look at that last box on that page. Okay, Benjamin? Ravi? Look at the last box on that page. We're almost done. So, we didn't talk about this when we talked about perpendicular and angle bisectors. So, when I have a perpendicular bisector, right? So, that's what we talked about last week. Those things meet at the circumcenter, right? So, you might be asked to identify the circumcenter. So you're looking for perpendicular bisectors. Angle bisectors meet at the in-center, right? So you might see a question where it asks you to identify the in-center. And then we have our medians and our altitudes, right? So this table here will be super helpful on your test next week.